So again, good afternoon from me. I'm Markus from Formlabs. I've been with the company for just over 2 years now, mostly being active in the DACH region, so the German, Austrian, and Swiss market. And yeah, as mentioned before, today I'm going to talk to you about the trends in additive manufacturing and the next steps that we are going to take to move additive manufacturing into production. As of today, additive is still considered a disruptive technology and thus more of a kind of experimental technology that's not really gone mainstream yet. So the first question that we have to ask ourselves is there a historic precedent where we had a technology that was considered disruptive but changed how we worked on a massive scale? And of course, there's an obvious example. We just have to look at computing. When we started to develop computing, we first went from the big mainframe machines in the 50s and 60s, developed by IBM. This was a technology that was only available for the highest value, most advanced projects. It was used in defense or in space research or space programs. By NASA, for example. I think most of you have heard this quote that's attributed to Thomas Watson, where he said, I think there's maybe a market for 5 computers in the world. I mean, most likely he never said that, but this is quite reflective of the sentiment about computing technology at the time, where it was just considered something super advanced and super niche. But I think, as we all know today, it didn't really stay that well. But we actually saw a development here. We saw computers getting more accessible. We moved from the big mainframe machines to telex machines that we use as a means of communication between offices, before email was a thing or before Slack was invented. And then we saw even further development where computers were moving into businesses and finally in the form of the personal computer in our homes. And today I'm pretty sure everyone in the audience is already carrying at least one computer around with them that's actually more powerful than the computers that were used to get us on the moon. Of course, I'm talking about our smartphones. And we see this development even continue further. Today, computing power has actually left the offices again, and it's taken to the cloud, it's stored online. All the heavy lifting is done by clusters in the cloud and not on site in our offices. And we see tiny computers in pretty much every device that we use today. We have them in form of IoT sensors, integrated technologies all around us. And this development is even to continue, where we're going to mix the virtual and our true perception of reality with augmented reality. So we can really see that this once niche technology became really all-encompassing and really widely spread around us. So how did we get there? Well, the key to getting there was making technology accessible. So the next question has to be, how do we make technology accessible? And the first thing we can do here is learning from Intel. What Intel did, they really advanced integrated circuit design, and they released the first commercially available microprocessor, the Intel 4004, which was a chip that was tiny and super powerful. And just by shrinking down the size of what we used to know as the big mainframe computers, just shrinking them down in size to this tiny, tiny chip that was super flexible and super capable, they opened up new applications. What followed was the x86 architecture that's so well adopted that's still powering most of our laptops of today. Like this machine in front of me is probably running on an x86 chip. So what we can learn from Intel is they took a technology that was already around, computing, and they took the essential parts, shrunk them down, and made them modular and flexible, and then just by the economics of scale, made them available. But we also can learn from Apple. Apple is always putting the user experience at the core of its business model. Steve Jobs said that the future of computing is in the graphical user interface. So they really made big advances in getting users to be able to use their products. And this is also something, like these two things are something that we are already seeing in 3D printing. We've reduced the cost of those machines from the early stages by 2 orders of magnitude today. And we've made them more easy to use. So they are not only used by scientists and experts, but pretty much everyone here is capable of using a 3D printer. And we also see this development from the big monolithic designs from the mainframe to a distributed, more flexible and better scalable structures. Even servers of today are not only single machines, but they're running on clusters and distributed environments. So what happens if we keep pushing this development? Well, we'll see prices drop. The cost of a 3D printed part as the technology advances one part will cost you less this year than it would have costed you the year before. And this is something that's kind of similar to Moore's law, where we see a steady increase in the capabilities or just the amount of transistors on a computer chip. What we see right now in the 3D printing industry is just a steady drop in the cost of 3D printed parts. And this will allow new applications just by lowering the barrier to entry. We started by really high-cost, high-value prototypes that were one of a kind. And then we moved on and used 3D printing in production. Then we were able to make high-value final products in the medical space or like hearing aids. And now we're even further, where we can actually 3D print athletic footwear. So we're now finally able to make consumer goods on a 3D printer. And if you're somewhat familiar with SLA, which is something that Formlabs does, you would know that 3D printing a material that's good for an athletic shoe is not that easy. It has to be flexible, it has to be wear resistant, and this is something that SLA materials are usually not known for, but this is something that we are able to do today. But we're actually to do a lot more in the consumer space. Today we're able to make a totally end consumer product, a razor, that you can design yourself. So you can get your own customized razor for less than $20, which is like a super cheap, super low price for a product that you designed yourself. So we've been able to achieve all this by just making this technology more affordable and more available to everyone. So what's going on today? Well, we see technologies evolving. Just to, again, talk about SLA, because I'm pretty familiar with that. The basic process of photopolymerization is moving in different directions right now. We see two-photon polymerization, which is enabling us to print really, really tiny parts. If you look at the scale here, these parts are all just a couple of millimeters, so we're able to print complex geometries at the micro scale. And this will open up all kinds of applications in the medical area. This will help us in the surface technology, where we can optimize topology in a way that we've never been able before. But we also see SLA evolving in a different direction with the clip technology, a super fast, super rapid technology that lets you print your final products in just a few minutes or hours. I think the long-term vision of the company Carbon, that's known for this technology, is to just move away from warehouses completely and just produce just in time. We're also making advances in the metal space with companies like Desktop Metal, really making desktop metal 3D printing accessible by driving down the costs here, by advancing the technology and also making it easier to understand. But it's not only the processes that we advance, it's also the materials that keep evolving. So we're seeing advances in all branches of 3D printing. We're seeing the SLA materials becoming sturdier, tougher, and more resistant than their injection molded counterparts. We're seeing new metal alloys being able to print like we could never before. We went from just being able to print one type of metal to print complex alloys. In the medical industry, we are making advances with biocompatible materials. We're able to print tissue material and even bones. And we're making advances in the composite materials, where we're able to print ceramics or loaded materials with fiber. But not only the materials that keep evolving, it's also the software industry that's adapting to this new type of manufacturing. We're seeing Autodesk making big strides in generative design, because the designers of today are not longer hindered by the traditional ways or traditional means of manufacturing. They're actually totally free to create totally new designs in whatever shape or geometry they want to. Generative design lets us take an idea and improve upon that idea through iteration. So we just set our goals, like we want to achieve like reducing the number of parts in a complex assembly, or we want to increase the strength of a load-bearing part, Or maybe we just want to optimize weight, and AI will help us coming up with a design that we could never think of. New software is also developed in the simulation of 3D printed parts, taking into account their unique properties from their manufacturing design. And they even can help us with optimized support structures for 3D printing, because that's also one of the big parts that we have to take care of. Post-processing to this day is still one of the biggest drivers in cost in 3D printing. And we're seeing companies like Desktop Metal making huge steps towards easing up this process, like helping the customer to remove support structures from metal 3D printed parts, which until now is still always a big hassle. We see specialized companies just built around the concept of automation of post-processing of 3D printed parts, like fully automated SLS depowdering solutions. We're seeing manufacturers experimenting with soluble support designs for their polymers. And we all do that with the aim to reduce the labor required in post-processing, because as we hopefully develop as an industry and the entire world, labor costs will hopefully go down, will hopefully go up, sorry. But this means we have to optimize our processes to be as little labor intensive as possible. And this, of course, leads us to the end goal where we have a fully automated, fully integrated robot optimized system where we can produce just with the help of robots, where no human factor is needed in the end. And this is the dream of creating a fully digital factory. So, yeah, as we're seeing where the industry as a whole is heading, I mean, this is a little bit the bigger picture stuff. Let's take it down a few steps and a bit more to the past. How is Formlabs contributing to that? Well, we just announced a new generation of our 3D printer, of our core product, and all with production in mind. So we have introduced in April the Form 3 and Form 3L. People were really happy with the Form 2. They loved the accuracy, they loved the surface finish, they loved the way they used it. But there was one thing they didn't particularly like about it. They wanted it bigger. So that's why we made the Form 3L. And what else did we improve? We improved the sensors. So now you don't even need qualified personnel to operate it, because the printer will tell you when something is wrong. We took a whole new approach to SLA. We reduced the main limiting factor in SLA, which is the peeling force, and we cut that by 90%. So now, with the new low-force stereolithography process that we developed, you only would need around 10% of the forces that you need before. I will demonstrate this process here on the slide a little bit. So we moved away from a sturdy tank to a more flexible design, where we have a flexible layer on the bottom, and the LPU, the new designed optics module, will move across that layer, and it will keep lifting up the print wherever it goes. This means there's at any time only a small area of the print actually touching the bottom of the tank, and thus greatly reducing the forces that are needed to remove the print. Also, as you can see here, the laser is now always perpendicular to the surface, and this will ensure a conform and stable accuracy throughout the whole build volume. Also, this LPU is user replaceable, so whenever something is going wrong, you can take care of it yourself. Also, this modular approach is what allowed us to build the 3L, because it's relying on the same technology. So what does that look like? Well, we're able to reduce the contact point of support structures, and this looks something like this. So yeah, post-processing done right. But we cannot just only release new hardware. Hardware always goes hand in hand with software. So we updated Preform. People loved about Preform the one-touch solution, that you can just enable one click and it will orient the print for you, and it will generate support structures for you and upload it to your printer. That is still there. You're still able to customize your print if you feel like you're more of an expert and you want to optimize every last detail. But now the Preform also allows you to remotely take care of your prints, like start them remotely. We will offer a deeper print queue management. When you collaborate with bigger teams, you can remotely organize your prints in your team, distribute them. And I see I need to move to the end here a little bit, so software is great. And I think we've still got another 90 seconds, so maybe I stop talking and let someone with a nicer voice take over. Or not.
Of the great products you use every day. now they can push their work even further. Introducing the Form 3 and the Form 3L. We've redesigned the print engine to make a leap forward in reliability and print quality, using linear illumination and a flexible tank to turn liquid resin into flawless prints. We call this low-force stereolithography, an advanced form of stereolithography that balances high detail and high speed. Use your time more efficiently with a printer you can trust to deliver results. Easily add printers to keep up with demand, and take advantage of an ever-expanding range of functional materials for rigorous testing and production. Collaborate across teams and locations as your business grows by starting prints remotely and moving through a shared print queue. Low-force stereolithography was developed to scale. Now easily print large, detailed parts in-house with the Form 3L. Whatever you're designing, wherever you're starting from, Formlabs tools help anyone make anything.
Thank you, John. Okay, and thank you all for your attention. If you do have more questions, I think we probably have like 2 minutes left, and if not, there's our booth. Feel free to walk over and talk to us.
Yeehaw! So thank you for this nice little talk. As bigger as better, he told us. That's my job here. And another big applause. He's wearing a suit today, and that's really, really great. So are there any questions to this marvelous guy from the audience? Don't be shy. If not, he'll be around there, and you can talk to him face by face, and we will say thank you again.